Hi everyone, this is the review for exam 3. So just like the review for exam 1 and 2, this is an example of what the exam might look like with some example how many points per question. And I will point out here that as all of the exams have had, this has the directions to show all work. If you have a correct answer with no work, it's worth 1 point. Or if you show work that was something we didn't learn in this class, you're also going to have points taken off for that, because the point of the exams for this course are to use what I show you, right? Because most of these concepts are things that you teach in an elementary or middle school. I know that you know how to do them and you know all these tricks to do them, but the point is that to evaluate if you know how to do them on the level that you'll be teaching your students. Okay. So the first question is a matching question. So we've seen these on the previous exams. So I'm going to go ahead and just start off with the letter side and fill in the other one. So the first one says that A plus C is C plus A. So this says that we can switch the order in which we add things, and that's the commutative property. The second one says that if we multiply and then add, it's the same thing as multiplying twice and then adding. And so this is the distributive property. The next one says that any number times 1, that value doesn't change. So that's the multiplicative identity. The next one says that if you take a fraction and multiply it by the reciprocal, you get 1, and that's the multiplicative inverse. The next one is a group of terms, variables, and numbers separated by operations. So whenever you see a group of terms like this, well, actually, all 4 of the preceding A through D are examples of a group of terms, variables, and numerators separated by operations, and all of those are examples of expressions on either side of that equal sign. Right, so A plus C is an expression, or 3 plus 2, or 3 divided by 2. All of those are expressions that take numbers and variables and operations and kind of put them together without an equal sign is an expression. Okay, the next one is when you add a number and its opposite, you get 0. So that's going to be the additive inverse property. The next one is the set of all numbers that can be written in a decimal form. So this was one of the equivalent definitions of real numbers. So that is real numbers are just the numbers that can be written as decimals. Every real number, it's like the number line, right? The real number line is the one we always deal with, and on the number line, everything is either a decimal or a fraction. It may not be a repeating or terminating decimal, but it's still a decimal. The next one is the set of numbers -3, -2, -1. It's 0, 1, 2, 3, which has whole numbers. It has 0, and it has the opposites of those things. So that is the integers. The next one, a number that can be written as some A over B, where A and B are integers and B is non-zero. So this is how we have defined the rational numbers in that set builder notation. The next one, the integer, that's the distance between an integer and 0 on the number line. So this is how we defined absolute value. K, an algebraic statement that equates two expressions. So this is an equation that equates two things. The next one says that we can multiply. We're trying to multiply A, B, and C. We can multiply B and C first, and it's the same thing as if we multiply A and B first, and that is the associative property. This next one is that when you multiply by 0, you're just going to get 0. That's the 0 multiplication property. And lastly, a part to whole ratio where the whole is 100 is how we have defined percent. Okay, so I went through these. There's a lot of them. You're going to be expected to know pretty much every property and all the definitions. But on the exam 3 information sheet, a lot of these are listed out. So I'm not going to claim that it's an exhaustive list. I may have missed something, but you should definitely know everything that's on the list. That's on the second page of the exam 3 information sheet. And then there was a page in the book that has a lot of these properties listed as well. Okay, the second one is to write the number 234 and 67 hundredths in words. And if you've paid attention during the videos to how I say words, that's all you have to write down. Is saying that this is 234 and so the decimal point. So anytime we've had a whole number and then a decimal part, or a whole number and then a fraction part, we always connect those using and. And then how many are there? We have 67 hundredths. Okay, you should know how to spell tenth and hundredth and thousandth and all of those. So this is 234 and 67 hundredths. So we need to know how to write decimals in words, but also in expanded form. And if you remember when we went through this in the videos, the book has a different expanded form than I write. I still write all of the expanded forms with powers of 10, just because it's consistent with how we've written expanded form before. So you essentially just identify all your place values. So this 1 is in the tens place, so 1 times 10 to the 1. The 3 is in the ones place, so that's 3 times 10 to the 0, because we know that 10 to the 0 is 1. The 4 is in the tenths place, and so remember, we just keep subtracting, right? We have this pattern where we subtract, it's 10 to the first, to the 0, to the negative 1. And then this 2 is in the hundredths, which is 10 to the negative 2. So this is how you write it in expanded form. It's just with powers of 10. Okay. So now we want to explain the process of subtracting the following two decimals using base 10 blocks. So if you're asked to do a question using a certain method, if you don't do that method, you're going to get points off. It explicitly says to use base 10 blocks, so you need to use base 10 blocks. And remember, whenever we use base 10 blocks with decimals, we always have to say what block represents 1. So since we only have the ones, the tenths, and the hundredths, I'm just going to have a flat represent 1. Because then we'll have flats and longs and the units. So a flat represents 1. You always have to put this if you're using base blocks with decimals. You have to say what represents 1. So remember our subtraction algorithm using base 10 blocks. We draw everything in the first number. So we have 3 flats for 3 ones, 2 longs for our 2 tenths, and 4 units for our 4 hundredths. So the first step is to draw the blocks for the first number. And these steps are necessary. You have to write them down because I tell you to explain the process. So that means give the steps of the process. So we draw the blocks for the first number. And then after that, we remove the blocks equal to the second number So we're going to remove the blocks equal to the second number, or the number you're subtracting. So I think it's always easiest to kind of start at the lowest value, because we need to remove 5. We need to remove 5 units. Well, we don't have 5 units to remove. So I'm going to regroup here. And remember, decimals are always in base 10. This question also tells you that we're using base 10 blocks. So if we regroup one of these flats, we're going to get 10 units. And now we can remove 5 of them. So you can use different colors if you want. You can also just label like, hey, this is a regrouping, but I'm going to use the black to regroup and red to remove. I will note, I would prefer if you don't use red pen or marker or anything on your exam, just because when I go back and grade it, it's easiest to do that in red. So avoid using red on the exam if you can. So we need to remove 5 units. Okay, now we need to remove 4 longs, but we only have 1 long left, so we can't do that. So we regroup this into 10 longs. So we regroup this into 10 longs, and now we remove 4 of them. So I'm going to remove this one, and then 1, 2, 3. There. And now we need to remove 1 flat. So we're going to remove this one. So the next thing that we do is we regroup and we count what is left. So the steps for this subtraction algorithm are the exact same steps for subtracting whole numbers using base blocks. It's this exact same algorithm. We just have that the flat longs and units represent different things. So what do we have left? We have, again, starting with units, 1, 2, 3, 4, 5, 6, 7, 8, 9 units left over. We have 7 longs left over and 1 flat left over. So we can see that whenever we do this subtraction, we get 1.79 is what we get left over. Okay. So now we've gone over how to do operations with decimals using base blocks. So the base block algorithms are the exact same as chapter 3. You just have to say which base block is going to represent 1. So now number 4, we can also add and subtract things using the model of the integers. So on the exam 3 information sheet, in addition to all of those terms to know, there's concepts to know. And so some of the concepts to know are using algorithms and models to do the operations with decimals, but also with integers. So this is our example on the review for using a model to do an operation on the integers. And we're going to use this one. So again, it says explain how, which tells you that you need to write the steps. And it tells you to use the number line. So again, you will get points off if you don't explain your steps. And you'll also get points off if you don't use a number line. Okay. So we have this number line, and you should be able to draw the number line pretty accurately because you know what the answer is going to be. So I'm going to start here at negative 12, 11, 10, 9, 8, 7, 6, 5. Sorry about that. 5. Oh no, sorry, it shook it and everything kind of got off. So let me start over here. So we're drawing our number line. And I'm going to start at negative 12. Okay, so remember, when we use a number line to add or subtract integers, we start at 0. And then we move to the starting number, so whatever number is first in our operation. So in this case, we're going to go from 0 over to negative 4. And remember that whenever we go to that starting number, we're always going to start facing right. So we move to our starting number facing right, which is negative 4. Okay, so then we have an addition sign, which our addition sign tells us that we keep facing right. And then we have a negative sign. So now we face left due to the negative sign. Right, so anytime you encounter a minus sign or a negative sign, you're going to change your direction. And so because right after that negative sign is the value 6, we are going to move 6 to the left. So we're going to move 6 to the left. So we go 1, 2, 3, 4, 5, 6. So we go 6 to the left, and this tells us our answer. Negative 4 plus negative 6 is negative 10. Okay, so that's how we use the number line. Okay, so again, make sure you know how to do using all of the models and the algorithms to do all of the operations for the integers and the decimal numbers. So next, we're moving on to scientific notation. So we want to write these numbers in scientific notation. Okay, so the first one is pretty simple. So remember that scientific notation, your highest place value is going to be in the ones. So you just need to move this decimal 10 times until you get a 3.45. So, oh shoot, sorry, I'm supposed to be writing in blue here. So you move this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times until you get a 3.45. And then how many times did we move the decimal places? We moved it 10 places and we moved it to the right. So this is going to give us a negative 10 because to move 3.45 to this decimal that's above, we would need to move the negative 10 to the left, which is towards the negative side of the number line. Okay, so part B. So this might look to you like it's already in scientific notation, but this is why on the exam 3 information sheet, I say that you need to be able to identify correct and incorrect scientific notation because the highest place value is always in the ones place. This one, it's in the 10th place. So we need to move the decimal here. So we get 9.8. And how did we just move it? Well, we moved it to the right. So to undo that, we would need to move it to the left towards the negative side of the number line. And then we had this 10 to the 5 here. So this 9.8 times 10 to the negative 1 is how we would write 0.98 in scientific notation, but we also had this 10 to the 5th. So to get this in scientific notation, you're going to combine the 10 to the negative 1 and the 10 to the 5th. And remember, when you multiply things like this, you're going to add the exponents. So this is going to be 10 to the, whoops, not negative 4, 10 to the 4th, because negative 1 plus 5 is 4. And I'm going to box these answers in. Okay, so that's scientific notation. So you need to be able to convert between standard and scientific notation, as well as identify incorrect and correct scientific notation. Okay, so again, we have a long problem where we just do a bunch of operations. So we had this on the last exam where we dealt with fractions. So these are all going to be, for this exam, these are all 4 points each. The last exam, they're all 3 points each. Okay, so this is going to assess, can you do operations using the order of operations with whole numbers? Can you do operations with decimals? Can you do operations with scientific notation? And it encompasses a lot. So make sure you can do all of these operations. And again, you're not going to have a calculator. If I see you using a calculator, you're going to get a 0 on your exam. Okay, so again, show all of your work. Show all of your scratch work in particular. Think about working these problems as if you're working them on the board in front of a class. Your students are definitely going to want to see every step. As someone who teaches college as well as high school, I can guarantee you your students want to see every step, as I'm sure you do as well. So show me every step on the exam. Okay, so -3 times the absolute value of 8 minus 10 plus 5. So remember that in our order of operations, PEMDAS, the parentheses include any grouping operation, and the absolute value sign is an example of that grouping operation. So we would do that one first. So -3 times the absolute value of 8 and 10. So the difference between 8 and 10 on the number line is 2 units. So that's a 2. And then we add 5. So remember, we multiply and divide first. So this is going to be -6 plus 5. Then we add and subtract. So this is -1. And you should put equal signs throughout all of that. Okay, next is doing these decimals. So remember, PEMDAS, we group multiplying and dividing, and we group adding and subtracting going from left to right. So since there's only addition and subtraction in this problem, we're just going to work them in order from left to right. So 6.5 times, or plus, my apologies, 0.75. So remember, whenever we add and subtract using decimals, we line up the decimal places. and add zeros on the end if necessary. So 0 plus 5 is 5. 5 plus 7 is 12. Carry the 1, 7, and we just carry the decimal point down. So this is 7.25 minus 2.3. And now I'm going to do the scratch work over here again. So again, we line up the decimals, add zeros if needed. 5 minus 0, can't do it, so we need to borrow. So this becomes 1, this becomes 15. Oh, I'm sorry, I make this mistake all the time. 5 minus 0 is just 5. We cannot do 2 minus 3, so we need to borrow. So we have 6, this becomes 12. 12 minus 3 is 9. 6 minus 2 is 4. So this is 4.95. Okay, good. So C deals with adding and subtracting integers. So 1 minus -7 minus 15. So again, this is only has adding and subtracting in it. So we're going to go from left to right. So we're going to start with -1 minus -7. So you can do this however you want. So we've talked about in the videos that we know that subtracting a negative number is the same thing as adding its opposite. So this is -1 plus 7. So you can go ahead and write it like this. You can use a number line, you can do anything, but I would recommend checking your work to make sure that you get the correct answer for this. So this is -1 plus 7, so this is 6. And then we subtract 15. Again, you can do this however you'd like, but this is going to be -9. I'm not sure if I said this explicitly in the videos, but the easiest way for me to do subtracting numbers in my head like this is to do the bigger one minus the smaller one, and then evaluate if it's going to be positive or negative. If that confuses you, you don't have to do it. But regardless, if you can't do this in your head, that's fine. You just need to be able to use a strategy and show me how you get the answer. Okay, so next, multiplying numbers with an absolute value. Sorry, with multiplying numbers in scientific notation. So remember that there's an implied multiplication sign here. And so we know that it doesn't matter what order we multiply things in. We have that multiplication is commutative as well as associative. So we rewrite this as 2.1 times 3.0. Well, we write this without the parentheses. So we do 2.1 times 10 to the 34th times 3.0 times 10 to the -14. We're going to switch the inside to using the commutative property. So this is 2.1 times 3.0 times 10 to the 34th times 10 to the -14. And so we can do these in any order we want. So if we do the first two first, sorry, let me rewrite these tens. They're not that great. So this is 10 to the 34 times 10 to the -14. Okay. So we can do the first two first. So 2.1 times 3, you can write out your scratch work to the side next to this problem, or if you can do it in your head, this is 6.3. And then to get the exponents, remember when we multiply 10 to a power, we just add the exponents. So this is going to be 10 to the 20. And this is incorrect scientific notation. So if it's not incorrect scientific notation, you probably should make it incorrect scientific notation, but this one worked out really nicely. Okay, so next is this division problem. So 1.44024 divided by 0.12. So remember, whenever we divide with decimals, we don't want to do that. So we just divide using whole numbers. So we change the number that we're dividing by, and we make it a whole number. So to do that, we move the decimal place by 2. To do it over here, we move the decimal place by 2. So now we are doing 144.024 divided by 12, right? Essentially, you just remember that division has an implied fraction here, and we're just multiplying that fraction by 100 over 100, which is equal to 1, which is our multiplicative identity, so it doesn't change the value. So whenever we divide with decimals, we want to change it to be division by a whole number, and then when we write it using our division symbol here, we're going to just have it like this, and the decimal place goes directly above it. Okay, So 12 can't go into 1, but 12 can go into 14 one time with 2 left over. 12 can go into 24 2 times with 0 left over. Bring down the 0, that's 0. Bring down the 2, that's 0. Bring down the 4, that's 2, with 0 left over. Okay, so this is 12.002. Okay, so lastly, dividing with scientific notation. So remember that we can just, like we did with multiplication of scientific notation, we can just divide each thing. So we can just divide the 10 to the power part as well as the numbers that come in front. So this is 15 divided by minus 5.0 times 10 to the 35 divided by 10 to the minus 13. Okay, so when you do 15 divided by negative 5, we get negative 3. That's just dividing whole numbers. And then we do 10 to the 35 divided by 10 to the minus 13. So remember, if that was a multiplication sign, we would add the exponents. But because it's a division sign, we're going to subtract the exponents. So this is 10 to the 35 minus negative 13, which is negative 3 times 10 to the 48. Because when you subtract the opposite of when you subtract a number, you're really adding the opposite. Okay, so you might go through and box these answers. I'll go through and do that in case you are doing this on your own. And then watching the video, you can easily find these answers. It gets a little bit more messy towards the end just because they're more complicated. Okay, but these are, again, not an exhaustive list of all of the problems you should be able to do, but you should expect to see operations using decimals, scientific notation, absolute value, things of that nature. Okay, number 8. So we want to solve this equation. We want to show our work and justify each step. So to solve this equation, you can do it in a lot of different ways. We showed examples in the videos of how to do this different ways, but most people like to do reverse order of operations. So most people like to do reverse order of operations, which essentially boils down to adding and subtracting, and then multiplying and dividing, and then taking square roots, doing things of that nature. Okay, so I'm going to subtract 6 first. So plus 6 minus 6. So my first step, and it tells us that we need to justify each step. We need to subtract 6 from both sides. So then when we simplify that, we just get 2/3 x equals 12. So this step is simplifying. Okay, so now to clear, right, we want to isolate x. So now what I'm going to do is I'm going to multiply 12 times. I'm going to multiply by 3/2 on both sides, which is the reciprocal of 2/3. Okay, when I do that, I know that when I multiply reciprocals, I'm going to get 1. So this is just going to be x on this side, and 12 times 3 divided by 2, which is, if you just multiply straight across, you can think of 12 being over 1. This is 36 divided by 2, and so x equals 18. And these steps are just simplifying. So you should show each step separately and give a reason for each step. You can go back and check your answer. We didn't talk a lot about that, but if you plug in 18 as x, you can simplify the initial equation to get 18. Okay, another scientific notation question. So we want to write each of these numbers in standard form. So to do that, it's just moving the decimal place. So remember, 3 positive exponents corresponding with moving numbers to the right, moving the decimal to the right. So we move the decimal place 1, 2, 3 spaces. So we have 2.3 times 10 to the third is 2,300. And on the other hand, we have that moving decimal places, a negative exponent corresponds to moving the decimal to the left. So I move it 4 spots. So 4.1 times 10 to the negative fourth is 0.12341. Okay. So lastly, we have percent problems. So we talked about section 7.4, we talked about the percent equation. So the percent equation is the part equals the percent times the whole. Or if we want to represent the part to whole relationship and equate it to some percent out of 100. So these were the two forms for the percent equation. So we want to know what is 25% of 48. So we know our percent and we know our whole. Well, that's going to be B is our whole. So we need to find our part. So we can say X equals 25% times 48. So you can solve this in a variety of ways. I'm going to convert this 0.25 to 1/4. And I know what 1/4 of 48 is. I know that that is just 12. So X is 12. Okay, so the next one is 10 is 20% of what number? So we're given that our part is 10 and our percent is 20, and we want to know our whole, the whole number that we're looking at. So this one I'll set up using the other form of the percent equation. So we have that 10 over our whole is 20 over 100. So we can, again, solve this in a variety of ways. The only way that you won't get credit for is if you cross multiply. A lot of people who tried to cross multiply in the last exam messed it up, got the answer wrong. So for many reasons, we're not going to cross multiply to solve this. But this one, it's really nicely set up because you can see that 20 over 100 is just the same thing as 10 over 50 when you divide it by 2 on top and bottom. So this tells us that B is 50. So 10 is 20%. You can write these answers probably in complete sentences. So 10 is 20% of 50. And for part A, we have that 12 is 25% of 48. So you should be able to read a problem, know that it's a percent equation problem, and set it up and solve it. Okay, so this is the review. Again, this is not an exhaustive list as stated in the Chapter 3 information sheet. The exam can cover anything from chapters 7 through 9. However, that in itself is a little bit misleading because chapters 7 through 9 rely heavily on things from the beginning chapters 1 through 6. So if something in chapter 7 through 9 relied, like, for example, this very first question about the algorithms, right? So, whoops. Oh, right. So this question about using the base block algorithms. Like I said, whenever we were going through this algorithm is the exact same as using base blocks to subtract in chapter 3. So you should know everything that we covered in chapters 7 through 9. All of that can be on the exam. You should know all of these terms. There's a lot listed in the exam 3 information sheet, so please check that out if you haven't. But if you have any questions over any of this, I'm always available in my office hours and by email. And I hope that this was helpful.